I'm Chad. I'm an architect here at Palantir. I spend most of my time helping our customers solve some of their most difficult business problems using different Palantir tools. And so I see a big flavor across different customers, different scenarios. And today I want to share a couple examples of what we see. Let's dive right into the content for today. So AIP on your enterprise is the theme. So our artificial intelligence platform and what it looks like to build integrated with an enterprise ecosystem you might have as well. All right, let's look at the topics. So AIP virtual tables, that allows us to connect different cloud data warehouses like BigQuery, Snowflake, or if you got Parquet files or Delta tables sitting in a blob store somewhere, we can connect those, register them into our ecosystem, and I can start building. It's pretty cool. We'll get into a little bit that looks like set up. Embedding generation, so we have some free-form text in that data. How do I create embeddings? Our pipeline builder, which is our low-code, no-code offering for building pipelines. And then the ontology and how we store vectors in the ontology and what that powers for us. And then semantic search. So how do I get away from keyword search to searching based on the semantic meaning of things? And then AIP logic, which is really awesome. It's our LLM-based functions across our ecosystem and how that plus our ontology really creates some pretty cool experience. And then our AIP assist is an application where we're going to build kind of that chat interface on top of your data using all the tools here that we're looking at. All right, so unlocking your unstructured data. These are the things that we're going to go build out today. And so I'm going to use this to keep us honest as we go through. We'll check this off and it'll be a little easier for us to follow. All right, so like I said, we call this a cooking show demo. The reason is I want to show you the end product first, show you the nice steak dinner that we're going to make. And then we'll go actually build this from the ground up. All right, so this is a workshop app. That's our low code, no code offering for building applications, interactive applications, as you can see here. This is a chat experience, and we'll put a prompt in here. This is using some notional data we'll look at in a second, but it's a manufacturing company called Titan. That's our notional data company. And we have data on trouble tickets from the manufacturing floor about the problem and the resolution from engineers. How do we leverage that so we can help reduce downtime by resolving issues quicker using past knowledge? So all that's sitting in free-form text fields today. How do we take that embedded knowledge in your business and leverage it like this? So you can see I asked a question about the ear loops on my mask are coming off. What should I do? This is pretty cool because now I'm using LLM functions that we're going to go build to navigate the ontology that is based on data sitting in BigQuery. So lots of really cool stuff going on here, and it summarized those past resolutions into things I should go look at to resolve my issue quicker. So this is what we're going to build, and this is what you'll see in the end. Let's dive in first and go back to, let's see, virtual tables. All right, so virtual tables. This is a great diagram. It shows, hey, normally we would have had to sync data in. Today now with virtual tables, you can just register it and pull it into your platform and start using it, even though it's still sitting, so no data copy. All right, BigQuery. So I'd said before, BigQuery is one of the offerings. Here's a BigQuery table. I've got all this unstructured data, these sample tickets I created with the problem and the resolutions. And so let's see what it looks like to register that. So in here in our data connection, you can see we can set up all sorts of different sources. I think we have over 200 plus different data connections. You can even create your own. And there's an SDK to go build them if you've got some in-house solution. So let's say BigQuery. All right, continue. We'll connect up here. So we're going to set up a direct connect. So this is going to allow us to go from our Foundry instance, whatever hyperscale it lives in, any of them. Ours happens to sit in AWS. So I'm going to actually connect from AWS to Google BigQuery in this example. Let's hit continue. And I got an awesome BigQuery data lake. That's my existing environment. And we are going to this here in our data connection folder. We'll keep things nice and clean. All right. Cool. And here's where I put in my Google project ID. And I've already set up an IAM account, a service account over in GCP. And so the service account has access to the BigQuery tables I showed you. And then here, since we know you're trying to connect to BigQuery, here are the 5 ports that we need to make that happen. And so we're very explicit to show you that here's the different egress policies that you need to allow Foundry to reach out to GCP. All right. Done. All right, I've created the source. Now let's start registering some virtual tables. All right, let's find a home for it. Data. As you can see, I like to keep things clean for all of our architect fellows. All right, the project ID. So right now it's getting the metadata from the catalog. So this is the initial setup. All right, so we've got the metadata from the catalog in BigQuery, and here's our trouble ticket table. I'm going to call this just trouble tickets and hit create. Awesome. All right, so I think that was like 2 minutes. So let's just go knock that off our list of things to build. Cool. All right, so this is a virtual table. You can see here's the data that's sitting in BigQuery, but it's actually now available here. And so you can see the source and everything. We're very explicit. I'll actually show you here. The table is stored in BigQuery, so I'm not incurring any storage costs. This just gets to live in BigQuery, no data duplication. All right, I hope I've hammered that point home. Let's go create a pipeline. All right, so again, for my architect fellows, let's keep this nice and clean to our pipeline here. If I can spell. All right. So we've got batch pipeline. You can also do streaming, but for today, we're going to do batch. So this is Pipeline Builder. This is our low code, no code environment to build out these scalable pipelines. It's backed by Apache Spark and Flink. So for streaming and batch or micro batch, you can do incremental builds, all that kind of stuff. Really cool because I can build these super easy pipelines, but they can scale to huge data sets. So if it's, the 17 rows I have in the data set here, but I've also used virtual tables with Pipeline Builder on tens or hundreds of billions of rows personally, and I see this same type of experience. But we'll go with this one today. And so in Pipeline Builder here, we're going to clean up some things. And you can see I can transform, join, union things. I can also connect a Snowflake table to a BigQuery table to something that's already sitting inside of our Palantir tools. So you can do all those in one pipeline. Today, we're just going to clean up this table from virtual table connection. So these two little purple icons, though, these are actually backed by AIP Assist. So I've got to generate and explain. So these are our LLM-backed functions. So we're actually going to generate a pipeline with natural language text. So I've already put one together for you here. And so I want to replace special characters anytime I've got this stuff coming in. I want to make sure I don't have special characters in the strings for embeddings and other reasons. And then I also, personally, I like typecase stuff. So I'm going to make my status column to be typecase. All right, so let's hit generate. So what's actually happening is it's taking the metadata about my existing pipeline, the metadata from the source tables, and the prompt and the intent. It's going through our language model service, so it's got a secure connection. And then we have our own private logless instance of GPT-4. For this use case, you can also bring your own models. We can get into that in another video, but for today, we're going to use GPT-4. It's going to go construct the pipeline here, and we'll actually have a usable pipeline. All right, done. So you can see our goal is actually to show transparently what's happening. You can always see the steps that an LLM might be taking. And then here we'll also see the output, and I can take that output and run with it, modify it, or just take it as it is. And so these are different boards. So these boards allow us to do different transforms. And here it actually generated regex. So it generated regex to replace special characters with empty strings, just like I had asked. It did that across all the string fields in my data set. And then as I had asked, I wanted to make the status column typecase. So very cool. These boards you can start to stitch together. Another neat thing is, as you can see, it actually did those transformations, and I can see a preview of the output of those transformations. So as I'm going, I don't have to build the whole pipeline and understand, is this working? Is it doing what I intend? I can actually see it going as I'm building a pipeline out. All right, let's go back to the graph. It says transform path. If anyone knows me, I'm terrible at documenting things properly, but having LLM by my side, I can actually have it know the intent of what I'm trying to do. Cleans and formats ticket data. It actually puts a description and title in here so the next person behind me isn't cursing me out. Let's go look at this here. So now we want to build a transform. So let's go look at that. All right, so we're going to do text embeddings. So we talked about text embeddings. So this is an embedding board. Real quick before we dive into that, I want to just talk about what is an embedding for anyone. Embedding is when I take text, I go through an embedding model, I get a vector, and the output of that vector is essentially the semantic meaning of those words coming in. And so you can see in this example here, this is an OpenAI model that we use today. I have different animal things like the sounds they make, and they're all closer together, so they're more related. So the closer they are in the vector space, the more related they are. The farther apart, the less related they are. And so I've got a quarterback throwing a football, totally unrelated necessarily to animals. The idea here is now I can have the semantic search allows me to not just go in keywords, but the semantic meaning to find things that might be related, but not using the same word. This is super powerful when I'm trying to work across maybe different dialects. I got people in South Africa and Boston and San Francisco using different terms for the same thing in my engineering group, but I want to still learn across all of them. So semantic search is a big key to that. It's also how a lot of the search functions work on when you're shopping and they find products that are similar based on you type in crazy things, and it will understand the semantic meaning of what you're trying to get and find products similar. Same thing. That's what we use embeddings for. All right, let's go back to build. So text embeddings, you can see this is using OpenAI's ADA embedding model in this example. And so we're going to go pick our ticket description, and we're going to have it put a new column. Oops, embedding there. And then we are going to go do another embedding, text to embeddings on the resolution. All right, let that run. And so now I have these two new columns I'm creating, the different embeddings on those text fields. It's actually making the whole calls to the ADA model through our secure endpoint again, and it's going to create the vectors for us. So you can see here are those vectors from those new columns. So now I've got vectors, I got cleaned up data. I want to put that into our ontology, and we'll see what that looks like. All right, look at it's already warning me that I didn't keep my documentation clean. Thank you. All right, new object type. So we're going to create an ontology object, and we'll talk through what that means in a minute. Titan, trouble, tickets, and we'll make it a little bug here and problems. All right. And let's pick an ontology that we're going to do this in. BT architecture. And then my ticket ID is the primary key. I want the ticket description to be the title property. And then you can see here on the embedding vectors that we put in, I want to pick what function we use to do the similarity, to tell the distance on that graph, like we were showing, the distance between two vectors. So we're going to use cosine similarity to do that. Awesome. All right, let's save. So a couple things I'll talk through here. You can see our pipeline. What we would normally go do is hit deploy, and let's actually look at some of those options. So like I said, this is backed by Spark and Flink. In this profile, I'm just going to use a single machine, super easy, but I can scale this up to extra large profiles. And then we even have custom profiles that can do, as large as you want, hundreds of thousands of nodes to do massive pipelines. I've used this with tens of billions of rows and scaled it up to hundreds of nodes, but you can really customize it to fine tune the performance. Awesome. So normally to deploy that, it takes a few minutes. So I'm just going to jump over to the finished one that I have here. So let's go to our data pipelines, clean. So this is the one I already did. You can see it looks exactly the same. It's already deployed though. So let's actually go look at that object and talk about the ontology for just a second. So what is the ontology? And so the ontology, yes, I have this structured data like we just talked about that we just built for the pipeline. There's things I can do here though that's pretty cool. It's differentiated. So the ontology, you think of as made up of data, logic, and actions. So I have action types, so I can create different actions. So it's not just, hey, here's a trouble ticket, but like, what do I want to do with it? Can I create new ones? Can I create an investigation? Can I close them? I actually can define those action types. They can write back to the ontology, but they also can write back to source systems. So if I have a trouble ticket system, I'll write back to, or work order system to send a person out, I can actually have those actions defined on that object. And then the logic piece. So you can actually create functions inside of here that allow you to embed models, if I wanted forecasting models, all this kind of stuff you can start to embed. So the ontology is really data, logic, action that allows me to map out my business. And so the goal of the ontology is to create the digital twin of your business process. It's a real-time knowledge graph of how you operate. So we get away from IT defined terms and we get into more, hey, how does my business actually operate? What does the ground truth look like? And that's the goal out of the ontology. So we can create links to other object types. And really the goal is to map out how your business really operates. All right, so get off my soapbox. That's our ontology here. And so now let's go back and talk about the next things we need to build here. So we already did that. We created embeddings. So now we have an ontology object that's based on our virtual table sitting in BigQuery. I've created those embeddings, ontologies there. So now how do I create the ontology-based semantic search? All right, I'm gonna jump back over here and we are going to look at our semantic search. So like I said before, when we're talking about embeddings, semantic search is so I can see the actual semantic meaning of words, not the keyword of them. So this is Code Repo. This is another tool inside of Foundry. This allows us to build different functions. I can do ones that do transforms like Python and Java and SQL. And here we're doing TypeScripts for functions. So I can build this function and register it as part of that ontology object. And so now, again, here is the, I had the data in there. I'm now going to create some logic about how I want to operate. So this is the logic component. And so in Code Repo here, you can see it's normal things. I'm going to import the ability to function with objects. I want to import the trouble tickets object we just created. I want to have access to the OpenAI embedding model, and we'll show you why in a second. But pretty cool stuff. So here I can see that these are the objects. This is the object type, the properties that I have access to now in this Code Repo. The other thing here is I've already registered this model import, so I've imported this actual live endpoint. So it's pretty neat. I already have some Palantir approved ones, so these are ones that we've put out here. Again, it could be Bedrock, it could be your own model, it can be all sorts of stuff in custom deployments. Here's just the one I'm going to use today. I've already imported this, and so that's a live endpoint. I'm actually going to use part of this TypeScript function. All right, into the functions real quick. I created two functions here, one for searching trouble tickets and one for searching the resolution. So search the problem and search the resolution. And all I'm really doing is I'm taking user input and the K value. The K value is find the 5 nearest neighbors or the 3 nearest neighbors. So that's what the K value is. And I'm going to return an array of trouble tickets. So that's the input. That's what I'm going to return. And here's where I take the user text input. I send it to the ADA model endpoint, and I get an embedding back for what a user might have entered in. So now I want to take what a user enters in from a search. As you remember in our nice steak dinner demo, I want to compare that against what's in the ontology. So that's a search. So I'm going to do a search on trouble tickets and give me back an object set. So this is where we say take the ticket description embedding. That's the column we just created in the pipeline. And I'm going to basically do a search and find the nearest neighbors, the nearest K neighbors, K value, from the embedding from the text that is coming in to the ones that are in the ontology. That's a search. It's going to order by the relevance. So order by, give me the ones that are the closest to the farthest for the how many ever you want. So this is the same function across both different columns, and I can use those. Base coverings, and we'll hit run. And so that's actually doing a semantic search. So this is showing you that running this TypeScript function is going to go find face masks because it's similar to face coverings, the semantic meaning of it. Cool. So now I've got I've got a semantic search function. So normally I would go commit this and take a version. I've already done that. We've deployed it out to the ontology. As you can see, I'm using it here. So if we dive into what's up next, so we've got a semantic search function. That's awesome. So let's mark that off our list and let's go back over. And now I want to build AIP logic. So let's go find our AIP logic app. All right, create new. And we are going to go here, create a new function. So AIP logic, like I said, is an LM-driven function for your ontology. So this is what it looks like. We'll get into how we actually go use it. So we're going to add a string input. So the string input would be the string coming from the chat feature I showed you in the end demo. So this is going to be the problem. It's going to be a string. We can add different blocks, whether it's variables or properties, or we can use LM blocks. And that's going to be the fun stuff. So you can see here in logic, I can actually start to stitch together logic blocks. It's a great name. All right. So in here, just real quick tour, I can select different models. So in here, I can actually have one logic block for LM using something, one model versus another model, and I can have various different models all working together based on maybe you have a model that's, you've fine-tuned your own LLM, or you've got your own model you want to use, or there's an open source model that's really good at some function you want to use. You can actually use those, bring them in. You can see there's a whole list of here, but you can also have your own or your own endpoint. All right, so you get that. Now I want a system prompt of what do I want this thing to do? And so I've already written this here. And so you can see you're an experienced engineer that can solve any mechanical issues. This is important to take your time and get it right. So this is how I want the LM to behave. And then we're going to give the LM tools. Well, here are the different kind of tool options. We'll walk them through them real quick here. So I have ontology functions. That's actually what we just created. We created a semantic search ontology function we'll use here in a minute, but let's go through the rest of the tools. Current date, so it knows its place in time and space. I can apply actions. So this LM, like I talked about with the ontology, I have actions in the ontology. Now think about it, an LM could go create an action to go move a trouble ticket or push a work order out. So actions allow you to actually move things forward and be really operational. A calculator tool, because we all know LLMs are terrible at math. And then it also query objects. So we give it access to very specific objects in the ontology. So as you create the ontology of your business, hey, I want it to only be able to go use these 5 different ontology objects. So you can actually specify and not fine tune, but limit down what the scope of this LM's access is to your business. Today, we're going to use the function we just created, and we're going to do the search trouble tickets. That's the function we just created. And so you can add multiple tools, and here I'm just going to give it one tool for this example. All right. And then we're going to have what's the input that I want it to go do. So here you can see I'm using variables. This variable is actually the variable coming in from up here, my problem variable. So that's the problem that an engineer is facing, and that's what's going to feed in here. So I'm going to say search for similar tickets based on the question from the problem variable, and look across these trouble tickets that are similar and find a resolution for those, and then summarize that for things that most likely will fix it, and then use it in bullet point. So I tell it how I want it to go, what I want it to go do, and it has access to this tool to do a semantic search across the ontology. Cool. And then so the output of this is the resolution. It's going to be a string. Awesome. So these things are great. Everyone knows LMs are non-deterministic, so like being able to test them is hard. So you think about API logic, there's really, like I would say the debugger is kind of one of the coolest things. So let's actually go test this out and see the chain of thought reasoning that's happening here. So I have an issue with face mask loops staying on. We're gonna run. So this debugger is actually going to show us both what goes in and out of each step, what tools it's using. So you can see this was the system prompt we put in, here was the task prompt. It decided to use the semantic search tool. And so here was that semantic search, the user text we had, that K value we talked about. It found it based on the output of the semantic search we wrote. And so these are the ontology objects that are most like it. And then it's going to look at those tickets and the resolutions of how the engineer resolved those and summarize those into a nice result here. So this is pretty cool. I had an LLM actually go navigate my ontology using semantic search and actually summarize all past resolutions so I can fix things quicker. Very cool. So this is a simple function. We'll have another video that goes in. You can really get elaborate with the blocks of functions. So I could add another LLM, like I said, and then you can output objects, actions, all sorts of stuff. All right, so let's go back, and then you can see here, we created our AIP logic function. Done. All right, what's up next? So let's go back over here to the end result. How do we build this? So we built all the pieces up here. What is this? So if I click edit here, we're going to edit module. So this is Workshop. I think I had called that out before. Workshop is the low code, no code offering. So drag and drop widgets that I then can configure on top of my ontology. And so you can see this is a widget with a set of configurations that I can do. This is another widget. I can configure all these things by dragging and dropping and moving things around. So pretty simple way to go do this. This cool chat widget, which I think was really what we're calling our Copilot constructor. This is where I can put, hey, this is your system prompt of the role of this agent. The agent has tools, and so it has access to Titan trouble ticket objects, has the tools. And so if we click on this real quick, you can see this is actually the function we created, the AIP logic function, the LLM backed function, that it has access to. So now I've got a chat agent that has access to an LLM backed function that has access to a semantic search function that can move across my ontology. That's pretty freaking cool. I'm just going to say it. All right. So you can do a bunch of different stuff and customizations about how this looks. You can name it, like I named ours, Frank. I love naming it whatever you want. You can have a little fun with it. Use different icons, a lot of different customizations in here. And then this widget over here is our logic. So this is like the chain of thought reasoning. So as we saw in that debugger where we saw the chain of thought reasoning, our goal is to be very transparent about what these LLMs are doing. And so the chain of thought reasoning is a great way so users can see what tools, how did it get to the answer that it's providing me, so I can build trust. I can understand it. Maybe I want to look at the object. And so that chain of thought reasoning is super powerful to do that. So that's as easy as it gets here. I could save and publish, and I'm going to go view it. Pop this out, and here we go. So when I click this is now, I'll just walk you through this. When I click this button, it's going to take this text, it's going to send it to my AIP logic function that we just created, right? And so now it's doing that, and you'll see here. So I can see Frank's using the user function tool, so the resolve me AIP logic function, the LLM back function, and you can see the chain of thought reasoning here on the right is it's actually showing all the steps, the objects. I can go click on these objects, investigate them, and it gave me a resolution, and boom, I got this nice text here. You can also dig in here and look at the different tools and pieces. Lots of neat stuff you can do here, but think about that. Now, all this stuff that's buried in your unstructured data, that's really hard to unwind or use in traditional like BI tools or other things, I create these interactive experiences. All right, let's jump back over to our deck. I think we finished all of it. Awesome. All right, well, I hope you enjoyed that. We're going to do some more videos that will dive into more complicated use cases, but I really wanted to show you something from end-to-end use case that we see across our customers and give you a flavor of like, hey, if I already have my enterprise sources set up, like how quickly can I actually get value with AIP and different Palantir tools? You saw how simple it was here today. Of course, you can add some more complexities and other things, and we'll dive into some of those things about how do I tune my embeddings? How do I create these more, how do I tune prompts? All those kind of things we'll dive into in some other videos. Thanks again. Bye.